as I explained in my last recording, I am currently, well, you see the background there actually. I'm currently moving files, well, backing up files from my laptop, my Windows laptop, to my USB stick, and yeah, it's taken a long time to copy all my programming files. Like, there's only 4 gigs left, but like, it's all the build files I have that like, there's like still over 78,000 physical copies, so and like that's just slow. Annoyingly, but yeah, whatever. I want to keep reading Category 3 for Programmers. That's what I'm doing, Category 3 for Programmers. So for those who don't know, I made a video on the 7th of August, now literally last week, 1 week ago exactly, and I meant to continue it, but I got sidetracked with async Rust and effectful programming and all that. So now I'm gonna get back to this and continue. Now that I know a bit more about effects, I can keep that in the back of my mind, and yeah. So let's find it real quick. Here's the book. As you can see, there's also like a lot of other stuff I want to read through. You know, these things take time, and I'm just one guy, and I still have to do stuff like apply for a job and, well, apply for jobs plural, and finish training for a job I do have, and all that lovely stuff. So progress will be fairly slow, unfortunately, in terms of like how much I progress through reading these books. Yeah, so here's the book. Now, there's so many chapters. I got also, I know that a lot of people have issues with this book, which is a bit scary, but I'm gonna keep reading until I feel like I'm no longer benefiting from it, or it gets too complicated and like I feel like the explanations aren't really sufficient. Because like there are loads of other books I want to read anyway, that people recommend more than this one, so I'm not gonna like force myself to read it if it gets kind of stupid. But I should be able to get through at least the first few chapters without any issues. Got my obsidian on deck as well. Over here, Category 3 for Programmers. Yeah, so you can see I got to chapter 1, and there was like the introduction. That seems to be an error over there. 1.3 should be like that. And yeah. So I didn't have that many notes to take out for the first chapter, because it was kind of stuff I already kind of knew about. It's more just like defining like these key points, I guess. And I did create notes off of it, I think. Yeah, like here, like I created this atomic note. In Category 3, every object in a category must have a morphism from itself to itself, known as the identity, right? So I'm creating atomic notes as I go as well, which I can build upon. Most of my notes here were honestly just like definition notes for like what words mean, which go into my cheat sheets, I think. Yeah, I have a vocabulary cheat sheet where like I keep track of words that are good to know. So see how many more of those I get. Those are, you know, those aren't the most productive, but they're still a thing. So I got these challenges. I think I'm gonna skip them. And yep, types and functions. I apologize if the text is a bit small. Unfortunately, I'm on a monitor that's like right in front of my face right now. Like because my desk is quite narrow, I can't really like move the monitor back, so I can't zoom in too much. But that also means that this is gonna be fairly small. Honestly, this is a fine text size. Honestly, the issue is that for some reason my thing is like super pixelated. Like when I watch back some of these videos, like the quality is so bad, and I don't know why. Like my settings haven't changed, but for some reason the quality just dropped. Like why is this such a bad bitrate? Alright, I finished looking at effect, coca, verse, a bunch of effects. This my camera, which is like whatever, and seems interesting. Like I think this quality is roughly correct. So that be in my head, and if I skip ahead, like special ASCII codes, whatever. Like this is zoomed in already. And like it's so I could just pixelated, it's weird. Have functions be, so I don't know why that is. I don't know why this is also tweaking right now. Let me just check my settings real quick. Settings, output, I mean, for recording, since my bitrate is 6,000 kilobytes per second, which wasn't an issue before, so I don't know. But point is, hopefully it's not too bad. I can also zoom in here, so I'll probably do that just a bit. Take more advantage of the screen space, and that should be okay for that as well. Yeah. So like you can't see my sidebar, but that's fine. Right. So anyway, so to recap, my notes actually. To recap, we had the preface, then we had what is a category in very simple terms, arrows as functions. So like we have our morphisms. We learned the rules of composition. So for A, B, and C, if there are the morphisms A, B, and A, B, C, then there's also the morphism AC, which is the composition. Same as function composition, right? That's nothing new, but like that's a general abstraction that goes beyond just functions, but also other things like functors and whatnot. Yeah, that was basically it. So now, types and functions. Awesome. Types. The category of types and functions plays an important role in programming. So let's talk about what types are and why we need them. Ooh, I also said that I'd probably look for a different PDF viewer, because note-taking on this is kind of annoying, for reasons I can't remember now, but I'm sure they will come back to remind me later. There seems to be some controversy about the advantages of static versus and strong versus weak typing. Let me illustrate these choices with a thought experiment. Imagine millions of monkeys at computer keyboards happily hitting random keys, producing programs, compiling, and running them. Yeah. Okay, there's a monkey. With machine language, any combination of bytes produced by monkeys would be accepted and run. But with higher level languages, we do appreciate the fact that a compiler is able to detect lexical and grammatical errors. While some monkeys will go without bananas, but the remaining programs will have a better chance of being useful. Type checking provides yet another barrier against nonsensical programs. Moreover, whereas in dynamically typed language, type mismatches would be discovered at runtime. In strongly typed language, yeah, okay. So you can kind of see through this. Yeah, Shakespeare, spell checker. Okay. Types are about composability. Category theory is about composing arrows, but not any two arrows can be composed. The target object of one arrow must be the same as the source object of the next arrow. Right, so let me first just create a new section here in my notes. So you have chapter 2, types and functions. Okay. So category theory is about composing arrows. About composing arrows. So I guess that's like the main point then. The main idea of category theory is the arrows. So I'll highlight that as a crucial point. But not any two arrows can be composed. The target object of one arrow must be the same as the source object of the next arrow. Yeah. In programming, so like A and B, and then B to C, is A to C. Like, if I have A to B and C to D, then that doesn't compose. In programming, we pass the results of one function to another. The program will not work if the target function is not able to quickly interpret the data produced by the source function. The two ends must fit for the composition to work. The stronger the type system of the language, the better this match can be described and mechanically verified. The only serious argument I hear against strong static type checking is that it might eliminate some programs that are semantically correct. Not really, though. In practice, this happens extremely rarely, and in any case, every language provides some kind of backdoor to bypass the type system when that's really necessary. Even Haskell has unsafe coerce, but such devices should be used judiciously. The hell? See what I mean by like vocabulary, dude? And the thing is, like, it's not wasting my time to look these up, because as I read more and more papers and stuff like that, I'm going to need the vocabulary. Adverb meaning to act with good judgment, wisdom, or care. Okay. Frank Kafka's character, Gregor... Oh yeah, this is annoying. I can't hide this. So like, now like Haskell is just blocked forever. And I can't hide the comments. Frank Kafka's character, Gregor Samsa, breaks the type system when he metamorphoses into a giant bug. Metamorphoses? And I know what the word is, but... And we all know how it ends. I don't know what that's referencing. Another argument I hear a lot is that dealing with types imposes too much burden on the programmer. I can sympathize with this sentiment after having to write a few declarations of iterators in C++ myself. except that there is a technology called type inference that lets the compiler deduce most of the types from the context in which they are used. Yeah, C++ is auto, and other languages have that kind of built in. Much more, well, by default. It's easier to use it. In Haskell, except on rare occasions, type annotations are purely optional. Programmers tend to use them anyway because they can tell a lot about the semantics of code, and they can make compilation errors easily to understand. Easier. It's a common practice in Pascal to start a project by designing the types. Later, type annotations drive the implementation and become compiler-enforced comments. Yeah. Self-documenting code. Strong static typing is often used... Hold on. Do I have a PDF? I've got this. Are there note-taking? There's highlights. No comments though. Note text. Yeah, no. That's what I want. And how about this one? That's document. Is this one? Yeah, I think these are the built-in ones. Right? Hold on, do the comments stay? Oh, they do. Edit notes. S. Can I like highlight this, highlight, and then add a note? I can. Okay, yeah, that works. I don't know why the annotations looks different though. Like the fact that these ones look different to the other ones is a bit weird. Color. Okay, I can't choose a color. Can I change my defaults here? Okay, let me look at this properly. Because if this is better, I want to use this. I mean, if it's sufficient, I want to use it. Edit. Okay, so we got good tools here. Like on Windows, for some reason, it was so hard to find a good document viewer. But on Linux, it seems to just come built in for KDE stuff. And there's dual mode. I can just press keybinds. Not quite. Okay. Dual page. Not a fan of it. Right, where are the settings for this app? There's keyboard shortcuts. It's not what I want though. There might be options somewhere else. Doesn't seem to expose it though. KDE document viewer. Oh no, that's this one. Yeah, this is the one I think I use on Linux. I mean on Windows, and it was kind of annoying to use. I can't lie. So not KDE. What's a GNOME? Yeah, this one. Boy, the fucking foot sends me. You can contribute to the app as well. That's kind of cool. Is it open source? So GitLab. What's it use? It's mostly C and a lot of Rust as well. Okay. Is it possible to change the default highlight colors on gnomes document viewer? It does have other color options, but I can't find a switch to toggle the defaults. Holy moly. There's this. It's still open. 2019? I'm not signed in. Let me sign in. Signing in with pre-existing gitlab.gnome.org. Oh, without. Oh, it's a specific website. Can I sign up then? Kind of weird. Sounds like a band-aid. We don't need an option, but remember the last color used for that purpose. How's that a band-aid? Just convenient. For the sake of art, please have a nice button with color to be used when creating an annotation. Unless they did implement that feature already. If I look at, that was 2019, it looks like the UI has changed quite a bit. Like if I highlight this, like yeah, like my options aren't really that great. Let's say I choose this color and do highlight that. Also, like why are these ones square, but these ones aren't? But there's annotation properties. Color this one, let's say. Highlight, yeah. So now if I do another one, it doesn't save. It's a bit crap. And why do these have square corners? Okay, I mean, like, obviously I'm fine to use a different color, but honestly, like, I don't like this color. Like, this is way easier to read. This one's just kind of, it's too thick. That's really annoying. How's that not a feature? That's crazy. Okay. I mean, I'd love to contribute one day to that. Yeah, now it's papers. And there's no, like, config. Okay. Which other PDF tool should I use then? I'm on Arch Linux. Can't spell, apparently. Zerno++. What I want is an app that's... what I want is to be able to highlight and add comments, comments to those highlights. That's it, really. Yeah. Alright, I guess it's Ocular that it is. Now, Ocular was not the best experience on Windows, but I do wonder if it'll be better on Linux. Just gonna make sure I don't already have it as well. I don't. Yeah, install. Hope it doesn't pull from source. It did not. Thank God. Don't save. Ocular. Doesn't quite look as polished as the GNOME apps, but. Downloads. Okay, there we go. I can zoom out. It also crashed a lot of windows actually. I think that was the main issue. Like it just crashed. But hopefully this is more stable on Linux. So now, yeah, here we go. So we got these comments. I can double click for comments. Okay. So like, let's say I were to highlight that. Okay, I can't highlight that too. Like the fucking like. Why do I need a browse button? Select text. Can I highlight it? Like, is it like it's really disconnected as well? I could use highlighter, but then like everything I touch highlights. Like why is text slashing separate from that? It's kind of problematic. Properties. There's color here. I can delete it like that. Properties here. This color. Add it to my custom colors. Okay. Okay. Configure annotations, edit this one, choose this color instead. I don't know what that means, text markup. What's inline note? Okay. Yeah. So highlighting basically. Okay. Remove this one, underline, yeah, just remove all that really. Okay, apply. Author is me. Give me the quick one. I can check my notes actually, that's pretty cool. I like that. It's a good feature to have. There's bookmarks and there's just the table of contents, right? Okay. Single page, continuous, good default there. Highlighter, text, browse. I know there are keybinds as well, but like the keybinds can change, I think, depending on the mode. And also there's some keybinds I can't change. Like it's 1 for highlighter, but to browse I do have to do control 1, then control 4 for text selection. It's like, it's really annoying. Also like I like to highlight text as I read, and I can't do that with this app. So it's just, yeah, it's really annoying. Check my settings really quick. Show menu bar, control M. Yeah, don't want to lose it. Toolbar shown. Right, so there's an annotation toolbar. It's way too much though. And there's a quick annotation toolbar. Is that this? For some reason I kind of warmed up the other. And then there's a main toolbar. Color scheme, there's dark mode. Okay, I'll use that. Language, shortcuts. Yeah, so here are the shortcuts. I think select. Yeah, like control +1. That's browse. So I can change this one at least. But like I don't want keybinds anyway. Like I want to just switch between the modes. Like just highlight and then press like highlight or something, you know? Like why can't I just highlight, right click, or like highlight and then like it shows like a button or something, or like a keybind to like highlight, like just something else. It's just so awkward. Configure ocular. Smooth scrolling, yes, scroll bars. Oh. Okay. Fucking scrolling is messing me up here. Performance, doesn't matter. Presentation, annotations. Editor. Okay, use that's fine. Yeah. My issue with Ocular is that it, for some reason, separates browsing, selecting text, and highlighting into different modes. I need to explicitly switch between. Not to mention that the keybinds for them aren't even well connected. Control +1 for browsing, Control +4 for text selection, and just 1 for highlighting. Freemium. Damn it, why is it so hard just to get like it'd be so easy to make a very simple PDF editor that just has options. Like, how are you not going to give me color options? That's so BS. Like, that's such a simple thing to implement, and you're not going to give it to me? In GNOME? And then like this shit, like with the modal whatever. Like, I like modal things, but like having mouse modality is so annoying. If even if the keybinds are easy, so like H to highlight or something, but like no, like it's just Control 1, Control 4, and 1. Like, what the hell? Like, I refuse to believe that the people who make these apps actually use them. But whatever. Again, I could make them better by contributing, but I'm sure there's probably like a conflict of interest there anyway. Maybe one day I can make my own PDF editor. In fact, how hard is it to make my own PDF editor? Viewer / annotator. A weekend or two. Use popular glib or mod positive. Parity to get 4 QT. Write valid PDF annotation objects. Handle text selection to quad point mapping. English you have updates right so you copy the file or fully write the XF table. Popular C++ API actually gives you highlights plus pop-up annotation classes directly. Oh, so Popular is a C++ for PDFs. More glowing UI events. A few weeks of evenings. Alright, so that's something to look into at some point. Not going to do it now, because I'm just trying to fucking read this, but... Okay, so... in Ocular, let me go to chapter 2. Switch to highlighter mode, select this text. Okay. And select judiciously. Like, okay. How do I, here? Dude, why are there so many buttons? Like, it's such a simple app to get right, but none of these things have, like, actual ergonomics in mind. It's insane. Okay, close that. Like, I can't tell if there are even notes anyway. This is another annoying thing, but it'll do for now. Close this. It's not even the right document. Ah, 1. Okay. File, save. Okay, that's good. Tools. Yeah, okay. Another argument I hear is a lot that dealing with types imposes too much burden on the programmer. Yep. Strong side of typing is often used as an excuse for not testing the code. That's good size, right? By the way, you may sometimes hear Haskell programmers saying if it compiles, it must be correct. Of course, there's no guarantee that a type correct program is correct in the sense of producing the right output. Yeah. The result of this cavalier attitude is that in several studies, Haskell didn't come as strongly ahead of the pack in code quality as one would expect. It seems that in the commercial setting, the pressure to fix bugs is applied only up to a certain quality level, which has everything to do with the economics of software development and the tolerance of the end user, and very little to do with the programming language or methodology. Right, a better criterion would be to measure how many projects fall behind schedule or are delivered with drastically reduced functionality. True. As for the argument that unit testing can replace strong typing, consider the common refactoring practice in strongly typed languages, changing the type of an argument of a particular function. In a strongly typed language, it's enough to modify the declaration of that function and then fix all the build breaks. In a weakly typed language, the fact that a function expects different data cannot be propagated to call sites. Unit testing may catch some of the mismatches, but testing is almost always a probabilistic rather than a deterministic process. Yeah. Testing is a poor substitute for proof. What are types? Testing is a poor substitute for proof. It's a cool statement. I don't even use testing that much. Like, I do it in Haskell a bit, when in Rust, I guess. Yeah. Testing is good, actually. I mean, I use it for, in OCaml when writing my compiler. No, my calculator. But yeah. The simplest intuition for types is that they are sets of values. The type bool is a two-element set of true and false. Type char is a set of Unicode characters like A or I. Sets can be finite or infinite. The type of finite or infinite. Finite or infinite. The type of string, which is a synonym for a list of char, is an example of an infinite set. Yeah, because the size. See, that's why, like, string, the type of string, because like type and size are two very interconnected things. But I guess string is like recursive in the sense that like there'll be a char and then another string, where a string is either a char or another string. So it is infinite in that regard, yeah. Like on like a theory level. When we declare x be an integer, we are saying that it's an element of the set of integers. Integer in Haskell is an infinite set, and it can be used to do arbitrary precision arithmetic. It would be infinite, actually, yeah. There's also a finite set int that corresponds to a machine type, just like the C++ int. So it could be either 32 or 64-bit. There's some subtleties that make this identification of types and sets tricky. There are problems with polymorphic functions that involve circular definitions, and with the fact that you can't have a set of all sets. But as I promised, I won't be a stickler for math. The great thing is that there is a category of sets which is called set. Is there? Oh, right. In category theory. What's a stickler? I presume it demands that things are done a certain way. Right. So just let me like, can I highlight this? H? No. What does H do? Top of page? Why? J goes down, K goes up, L jumps forward. I mean, actually, okay, so it's like Vim keybinds, I guess. That's quite handy, actually, to be fair. Except it's not, because I need to hide the text, but... Okay, fine, whatever. Highlighter... Highlight text? What? Like, how is that not weird as hell, bro? Oh god, bro. Okay. The weird thing is that there is a category of sets, which is called set. And we'll just work with it. What do you mean? In set, objects are sets and morphisms. Arrows are functions, okay? So like that's like the math like we're used to. In set, objects are sets and morphisms are functions. Set is a very special category because we can actually peek inside its objects and get a lot of intuitions from doing that. For instance, we know that an empty set has no elements. We know that there are special one-element sets. We know that functions map elements of one set to elements of another set. They can map two elements to one, but not one element to two. Set notation, actually, for types. It's interesting. Just thinking like in terms of like a programming language, like the unit type would be an empty set. Not really though. I mean, yeah, not really. It's the set of the unit type, is what it is. Because an empty set would not be assignable to anything. Because like the empty set does not contain itself, I believe. 4 minutes left. Okay. We know that functions map elements of one set to elements of another set. They can map two elements to one, but not one element to two. We know that an identity function, well, I mean, this is definitely assuming you know quite a bit about set theory. Luckily, I do. They can map two elements to one, but not one element to two. We know that an identity function maps each element of a set to itself, and so on. The plan is to gradually forget all this information and instead express all these notions in purely categorical terms. That is, in terms of objects and hours. Yeah. See, that's probably one of the harder things about getting introduced to category theory. Is not conflating it with type theory. Sorry, with set theory. Like categories are not sets. Morphisms are not functions. It just so happens that well, not so happens, but rather functions are a type of morphism, and there is a category of sets where the objects are sets. But like category theory itself is not set theory. Same with like type theory. I believe type theory is like another branch of, like, subset of category theory. We know that, but I don't know much about that, to be fair. So, I mean, unfortunately. So far, the plan is to gradually forget. Okay, in the ideal world, we would just say that Haskell types are sets, and Haskell functions are mathematical functions between sets. There's just one little problem. A mathematical function does not execute any code. It just knows the answer. Which is interesting, right? Like, you can't have mathematical functions for a programming language. What you can do, though, is generalize mathematical functions into category theory, and then use the category theory to have special different kinds of things. So like you have things that seem function-like, but have different properties than mathematical functions or set theory functions. A Haskell function has to calculate the answer. It's not a problem if the answer can be obtained in a finite number of steps, however big the number might be. But there are some calculations that involve recursion, and those might never terminate. We can't just ban non-terminating functions from Haskell because distinguishing between terminating and non-terminating functions is undecidable. The famous halting problem. Right. So that's the halting problem? Because like I've heard of it, but I've not been introduced to it. So the halting problem simply states that that proving a function as terminating or otherwise is impossible, or at least, yeah, well, impossible. I mean, you can ban recursion, but that would obviously exclude a lot of recursive functions that are terminating. That's why computer scientists came up with a brilliant idea, or a major hack, depending on your point of view, to extend every type by one more special value called the bottom, and denoted by this or Unicode this. Right, so I've seen this in type theory. So that's good. This value corresponds to a non-terminating computation. So a function declared as bool to bool may return true, false, or bottom. Why is it called bottom though? The latter meaning that it would never terminate. Okay. So special value called the bottom, denoted by this or Unicode this. Why did I highlight twice there? But what? I have to go to browse mode, delete the wrong one, go back to highlighter mode, click on this, yeah. Okay. So the bottom value denoted by this. Or Unicode of this. The bottom value, boom, means that means the results of a non-terminating, wait, no? A non-terminating computation. Yeah, it means a computation which does not terminate. So like it's not a value per se, which is the interesting thing. Interestingly, once you accept the bottom as part of the type system, it is convenient to treat every runtime error as a bottom, and even allow functions to return the bottom explicitly. The latter is usually done using the expression undefined. This is Haskell. There's definition type checks because undefined evaluates the bottom, which is a member of any type, including bool. Okay. Functions that may return bottom are called partial. Okay. As opposed, see, that's important there. As opposed to total functions, which return valid results for every possible argument. Because at the bottom, you'll see the category of Haskell types and functions referred to as Hask rather than set. What? What? The category of Haskell types and functions referred to as Hask. In general? Where? For this book only? My copying finished, by the way. From a theoretical point of view, this is a source of never-ending complications. So at this point, I'll use my butcher's knife and terminate this line of reasoning. From the pragmatic point of view, it's okay to ignore non-terminating functions and bottoms and treat Hask as bona fide set. What the f... Okay. This paper provides justification for ignoring bottoms in most contexts. It's a PDF. I assume it's a link, right? Oh, what? Wait, what? Downloading the PDF cached this PDF. That's so weird. So I like how it doesn't remember. Yeah, like it's a file on my system. That's so weird. Functional programmers often reason about programs as if they were written in total language. As if they were written in a total language. How do I there? Such two languages are defined, which are normal partial, technical syntax, semantic partial language includes partial and infinite values. Okay. That'd be a cool thing to look into later then. Keep it in mind, I guess. Highlight that. What? What is this? Why is it highlighting like this? Like, is it broken? It just created two different highlights. How does that happen? Like, the software doesn't even work, man. Like I do like dogging on like open source software, but like, is this literally the best we have in our community right now? So can I click this? I can. Okay. Would be good to read, or it could be an interesting read. Okay. What's bona fide? in good faith. Something genuine, real, sincere, or done without fraud or deceit. But what? I had to go to text selection just to double click it? Or browse mode? What the hell, dude? Meaning in good faith, without malintent or deceit. Latin. Yeah. Like, you can't convince me that the person who made this uses the software for highlighting and note-taking. Why do we need... Also, to be fair, Obsidian does have also a built-in one. It's worth checking in Obsidian. The thing is, I can't open it in Obsidian without importing it into my vault. And I don't want to import it into my vault. Because... storage reasons. Like this PDF. This PDF takes 50 megabytes. Which, like, it may not sound like a lot, but, like, there are limits to how much you can put. To be fair, 50 megabytes. Should I? Let me save. Let me close this. Open file in my file explorer. Let me move this to my vaults, which I think is over here. So documents. And in Obsidian, I'm going to create a new folder. Called PDFs? No. It should be here in sources, really. A new folder called local copies, let's say. Right? And let's add to that. Can I drag this in? Did it copy it or did it move it? Sources, local copies. Yeah, no, it didn't move it. It created a new one. Which is probably fine, to be fair. Except I can't see it for some reason. It says 0 pages. Okay, so that didn't work. That's what I'm gathering from that. Let me move it manually then. Milewski into Brainlet. I can only copy it? No, I can move it. That's weird. Okay. So here it's here. That's weird. It says 0 pages. Is the format just not good? Okay, then forget that. I just can't do that apparently for some reason. Hi. Why can't things just work? I may have just deleted it. Thankfully it'll be in my trash. Thankfully it'll be in my Obsidian trash. Yep. We'll take... Yeah, so that's a copy. So I'll take this one, put it in my documents. Okay. Open documents. There it is. Okay. Why do we need the backup model? As a programmer, you are intimately familiar with the syntax and grammar of your programming language. These aspects of the language are usually described using formal notation at the very beginning of the language spec. But the meaning or semantic, well, I guess so. Maybe that's why so many people like rush into bad syntax, because like they learn how to do this. They create a formal notation, and then like, quite rightfully, you know, they're resistant to changing their syntax because it's like they have to reevaluate their entire grammar. Like I've not created a formal spec yet. I mean, well, I haven't defined my spec in formal notation yet because I want it to be as flexible as possible. So I can change it at a moment's notice without having to like update some like long list of notes or whatever. It takes many more pages, is really formal enough, and the meaning or semantics of the language is much harder to describe. It takes many more pages, is really formal enough, and almost never complete. Hence, the never-ending discussions among language lawyers and a whole cottage industry of books dedicated to the exegesis of the finer points of language standards. But these terms, exegesis. A deep and careful study of a piece of writing to find its true meaning. Pulling the real message rather than forcing your own ideas out of it. I see. Yeah, so like a deep and careful study. A deep and careful study of a text without, projecting one's, that aim to be faithful to the original intent and meaning without the researcher projecting their own ideas onto it. No, faithful to, no. To find the true meaning without the researcher putting their own ideas onto it, yeah. They are formal tools for describing the semantics of a language, but because of their complexity, they're mostly used for simplified academic languages, not real-life programming behemoths. Yeah. One such tool, called operational semantics, describes the mechanics of program execution. It defines a formalized, idealized interpreter. The semantics of industrial languages, such as C++, is usually described using informal operational reasoning, often in terms of an abstract machine. I mean, C++ is definitely an extreme example, if not the most extreme example. The problem is that it's very hard to prove things about programs using operational semantics. To show a property of a program, you essentially have to run it through the idealized interpreter. It doesn't matter that programmers never perform formal proofs of correctness. Sorry, what's this called? Why do we need it? It doesn't matter that programmers never perform formal proofs of correctness. We always think that we write correct programs. Nobody sits at the keyboard saying, "Oh, I'll just throw a few lines of code and see what happens." We think that the code we write will perform certain actions that will produce desired results. We are usually quite surprised when it doesn't. True. That means we do reason about programs we write, and we usually do it by running an interpreter in our heads. True. It's just really hard to keep track of all the variables. Computers are good at running programs, humans are not. If we were, we wouldn't need computers. Interesting. Very interesting. Yeah, like we kind of have to run it in our head, don't we? But there is an alternative. It's called denotational semantics. I've heard of this, and it's based on math. In denotational semantics, in fact, it might have even come up earlier in this book. With that, every programming construct is given its mathematical interpretation. With that, if you want to prove a property of a program, you just prove a mathematical theorem. You might think that theorem proving is hard, but the fact is that we humans have been building up mathematical models for thousands of years, so there is a wealth of accumulated knowledge to tap into. Also, as compared to the kind of theorems that professional mathematicians prove, the problems that we encounter in programming are usually quite simple, if not trivial. Consider this definition of a factorial function in Haskell, which is a language quite amenable to denotational semantics. Amenable means like similar? Open your friends when to agree or ready to incorporate. Yeah, like a friend is the word that comes to mind. I swear there's like a language that has that. Where like the word for friendship is similar to this. Maybe it's I think amistad in Spanish. Or probably the other Latin languages. Romance languages. Meaning, open to influence, ready to cooperate, or willing to agree. fact n equals product of 1 to n. What's fact? Factorial. The expression 1 to n is a list of integers from 1 to n. The function product multiplies all elements of a list. That's just like a definition of factorial taken from a math text. Compare this with C. I see. Okay. Yeah. Need I say more? No. Int factorial, int n, int I, int... Well... Okay, no. This isn't fair, okay? Loads of things do this. This isn't fair. I can write int fact, int n, and then have the body just be product of an array, or I guess a vector, of 1 to n. Or like have a function that produces a vector from 1 to n. Now this is C, not C++, but yeah. Okay, I'll be the first to admit that this was a cheap shot. A factorial function has an obvious mathematical denotation. An astute reader might ask, what's the mathematical model for reading a character from the keyboard or sending a packet across the network? Great question. For the longest time, that would have been an awkward question leading to a rather convoluted explanation. It seems like denotational semantics wasn't the best fit for a considerable number of important tasks that were essential for writing useful programs, and which would be easily tackled by operational semantics. The breakthrough came from category theory. Eugenio Moggi discovered that computational effect can be mapped to monads. This turned out to be an important observation that not only gave denotational semantics a new lease on life and made pure functional programs more usable, but also shed new light on traditional programming. I'll talk about monads later when we develop more categorical tools. Nice. Because like usually if you learn about category theory from Haskell, or like you start from Haskell, you're probably gonna start with monads. But you can't really start, like, it's so hard to start on monads, because then you're hit with, like, a monad is a monoid in the category of endofunctors, and then you need to try to figure out what a monoid is and an endofunctor. I mean, an endofunctor is, like, fairly simple, but, like, you need to understand, like, what a functor is, but, like, a monoid is quite hard to explain. I believe it's like, a category with, like, certain rules or something like that. So, like, it's in the category of endofunctors as well, like, it's a monad that's also it's not simple. Before that, there's a thought. We usually do it by running it in our heads. So, I have a wonder. Oh, for fuck's sake! I have a wonder. Do we have to program it this way, or is there a different way in which we can understand and reason about our programs as humans? That's my question. Without thinking too deep about it right now. One of the important advantages of having a mathematical model for programming is that it's possible to perform formal proofs of correctness of software. Jesus. Sorry, one of the important advantages of having a mathematical model for programming is that it's possible to perform blah, 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 blah. This might not seem so important when you're writing consumer software, dude, but there are areas of programming where the price of failure may be exorbitant or a human life is at stake. That's true. But even when writing web applications for the health system, you may appreciate the thought that functions and algorithms from the Haskell standard library come with proofs of correctness. Yeah, dude, I hate how what's the term? Yeah, consumer software like can afford to be absolutely terrible. It's so annoying. What does exorbitant mean? Boy, how there's so many words I've never seen before in my entire life. Exorbitant is an adjective that means a price, amount, or demand is much too high and goes far beyond what is, yeah. Like extortion, right? Maybe? Extortionate, exorbitant. Okay, no. That's weird. Yeah, it's a synonym, but it's not. Because like, it looks similar, doesn't it? So I wonder if they're related. Exorbitant. Like demanding in this context, right? So what basically means. Yeah, like too high. Meaning like higher than is reasonable. Or like much too high. much too high than is reasonable. Exorbitant. Etymology. Because of Latin words exorbitans meaning deviating from the track or going out of orbit. Combines ex, which means out of, and orbita, a wheel. Right, so how about extortion? That's torsionate. But torsion is like twisting? To tort? Yeah, but orbita also means like to orbit. So like to twist, to rotate, to orbit. Extorsional. Like when we say extortionate, it's like you're getting twisted out of your money, you know? Exorbitant, extortionate. So again, ex and et from the verb extorquere and torquere to twist, yeah. Interesting. Yeah, it's kind of funny how that works, isn't it? Something that has leaped out of its normal wheel track. So out of its wheel track. Wait, then what's extortion then? To wrench or twist something out of someone by force. Wow, interesting. Okay. Quite different then. But very similar as well at the same time. Okay. The thing is, I don't know like how proof safe Haskell is. Pure and dirty functions. Dirty. With things you call functions in C++ or any other imperative language are not the same thing mathematicians call functions. A mathematical function is just a mapping of various values, yeah. We can implement a mathematical function in a programming language. Such a function, given an input value, will calculate the output value. A function to produce a square of a number will probably multiply the input value by itself. It will do it every time it's called, and is guaranteed to produce the same output every time it's called with the same input. The square of a number doesn't change with the phases of the moon. Also, calculating the square of a number should not have a side effect of dispensing a tasty treat for your dog. A function that does that cannot be easily modeled as a mathematical function. Yeah, I will say, just as like a side note, so far this is quite easy to follow. Like, I'm enjoying this style of writing so far, which I cannot say for many other things. What is 20380498? Oh, that's cool. So it also knows the page numbers, like, of the actual book. It's kind of cool. In fact, we're roughly like a 25th of the way through the book. We can implement a also calculating the square of a number, yeah. In programming languages, functions that always produce the same results given the same input have no side effects are called pure functions. In a pure function language like Haskell, all functions are pure. Right, but there's a meaning to pure in Haskell that isn't the same as the mathematical notion, is what I'm told. I think apparently pure in Haskell does not mean the mathematical term. What it means is a function that is deterministic, which means a non-terminating function is pure. And a function that can throw exceptions is also pure, as long as it is deterministic. So it's not quite the same. But like, I guess you could mathematically model non-termination and like an exception as a kind of output. Just have it like added to the set. So I guess to that sense, it could be considered compatible with the mathematical notion. It's more so that like it's more like the difference between like a pure function and a total function. In a pure function language like Haskell, all functions are pure. Yeah, because of that, it's easier to give these languages computational semantics and model them using category theory. Wait, all functions are pure? Is that true? Are all functions pure in Haskell? Like an IO function is not pure, but like I guess it's modeled as if it is pure. As for other languages, it's always possible to restrict yourself to a pure subset, or reason about side effects separately. A2 will see our monads let us model all kinds of effects using only pure functions, so we really don't lose anything by restricting ourselves to mathematical functions. Examples of types. Once you realize that types are sets, you can think of some, well, types are sets again on like a theoretical model, but when it comes to size and implementation, like what is a U32 or a U8? Like a U8 is an integer that's unsigned of 8 bits, So you know the set includes values from 0 to 255. Like that's a set of values, but the actual implementation is a sequence of bits that are interpreted as an integer. So really, a U32 is not so much a type as it is a morphism from a sequence of bits, specifically a sequence of 8 bits. So the set of 8 bits, you could say, but like there is order to them as well. So like let's say you label them as like most significant bit 1, next most significant, so like bit 1, bit 2, bit 3, bit 4, bit 5, all the way to 8. And U32 is a morphism from those 8 bits to the set of integers from 0 to 255, right? So once we realize the types of sets, you can think of some of other exotic types. So let me take a note of that, because like this relates very heavily to how I'm gonna kind of model types in my language. Yeah, but not really. Okay. Types are sets in. Types are only sets on a theoretical level. For example, take U8, for example, or U int 8, for example. On a theoretical level, not even, like, abstractly, it is the set of integers from 0 to 255. But concretely, it is implemented as a sequence of 8 bits. I would argue it is more accurate to theoretically model a U int 8 as a morphism from a set of 8 bits ordered by significance, e.g., you know, B1, B2, B3, B4, etc. I'm worried that this is really small text as well, so you can't really see it clearly, but good thing I'm seeing it as I go. To the set of integers from 0 to 255. Yeah. It's kind of interesting, isn't it? It means that like when you interface with the type U32, you're really just activating functions that will convert it to and from the bits, which is kind of cool. So that the type just contains information, you know? Like, a U32 is at its core a sequence of bits, but there exists morphisms to convert an integer to the bits. Or perhaps it is better to say that a uint32 object, so uint8 object, is simply a sequence of bits that are either on or off, and there exists a morphism from the to and from. Well, no, morphism to and from the set of integers from 0 to 255, from/to the sequence of bits. Yeah, that's quite satisfactory so far, based on my understanding. For instance, what's the type corresponding to an empty set? No, it's not void. It's not void. Why is it not C++ void? Because void doesn't contain any values. No, it's not C++ void, although this type is called void in Haskell. It's a type that's not inhabited by any values. You can define a function that takes void, but you can never call it. Why not? To call it, you'd have to provide a value of the type void, and there just aren't any. Right. Right? That's why unit and void are separate, by the way. Like, void is like nothing. Like, it is the empty set, you cannot provide anything. For unit, you can provide the empty unit value. And that's the value, and that's the value that you're providing. But like, I feel like conceptually for a function, like, you can just say, like, just say, like, there is no value being passed. As opposed to, like, it is the unit value being passed. Like, right? Like, surely that's, like, up to interpretation. Or, like, how you choose to kind of view it. But, okay, from this agreed upon theoretical standpoint, void is not callable. As for what this function can return, there are no restrictions whatsoever. It can return any type, although it never will because it can't be called. That's interesting, actually. Hold on. Because that means I can make a function uncallable by making its type void. That's interesting, right? I mean, it's call type void. Like, I could map public and private access in terms of the type signature being void, or like giving it like a void wrapper so it cannot be called, right? And only those with like permission have it. In other words, it's a function that can't. Haskell have a name for it. Absurd. Okay. Yeah, so first of all, I take it that this is why the unit type exists, since it does contain one value, unit. But you can never call it. I wonder if public/private access can be modeled in this way, where private functions are exposed to the user as void, whereas it is internally a variable with its normal input. Remember, A is a type variable that can separate any type. The name is not coincidental. There's a deeper interpretation of types and functions in terms of logic called the Curry-Howard isomorphism. Right. The type void represents falsity, and the type of the function absurd corresponds to the statement that from falsity follows anything, as in the Latin adage. Of course, like, before showing the Latin statement, it then uses another word that I don't understand. The Latin adage, ex falso sequitur quod libet. Quod libet. Ex falso sequitur quod libet. Quod libet? Well, that's French. Ex falso. Wait, so is it like non sequitur? Like the fallacy. But learning Latin would like be so. To be honest, now that I think about it, learning Latin would actually not be that hard. It's probably like a decently regular language too. To be fair. And like the form of Latin is a lot closer to English, I think, than like Spanish or Italian. Actually, no, that's a lie. Forget that. That's a lie, because it was the Spaniards and the French who influenced the language, not the Latins. or the Romans. At least not as much as the French and Spanish did. The Curry-Howard isomorphism. The type void represents falsity, and the type of the function absurd corresponds to the statement that from falsity follows anything. Yeah. I know that. Oh, does it say X from false follows anything? Maybe. Okay. One at a time. Adage. A short, traditional saying that expresses a common observation or a general truth about life. What? I swear there's another word for this. A proverb. Yeah. An aphorism. An aphorism. I've heard of aphorism. In fact, I'm pretty sure, no, he hasn't used it yet. Wait, yeah. Has he used the word aphorism in this as well? Meaning similar to aphorism, meaning a short traditional saying or proverb expressing a common observation or general truth about life. Can I control F to search? I can. Aphorism. Seriously? I could have sworn it was used here. Okay. Maybe it's just in my notes separately. Yeah, it is. First seen, oh yeah, on that post, that's right. Okay. Okay. Ex falso sequitur quod libet. Well, I don't know how to pronounce like Latin. Latin. Let's type it actually. From a falsehood, anything follows. The principle of explosion. Yeah. This takes like a lot of time to get used to, honestly. I still don't really understand it. Wait, double bar means or? Are you serious? I don't really understand. To be fair though, it's double bar is like one symbol, whereas and is just the one and. Wait, what the why is he using C programming? I assume this is like for computer science, because like I swear maths does not use these symbols. Yeah, let's not standardize this. But yeah, like when I first learned about this, I just couldn't wrap my head around it. Like, if I say unicorns are real, therefore the world will end tomorrow. Right? Or like rather, the fact that unicorns are real implies that the world will end tomorrow. Like that is a true statement. Somehow in logic, that is considered a true statement. And I believe there are other, like, not branches, but like conventions or like understandings of logic or like systems of logic in which that isn't the case. But for some reason, the most successful one, at least the most popular one, is the one in which that statement is true. Which is weird, right? Well, it really is phrased more like, if you accept the premise that unicorns are real, then the world will end tomorrow. So, that's more how it works, right? Which means if I deny the premise, then that isn't necessarily true, at least. Which is good. No, I lied actually. No, I lied. It means that even if you consider the first statement to be false, the second statement is true by implication. Again, it's hard to explain. I don't understand it that well. despite thinking about it, like doing genuine research into it, I got books for that stuff, and I still just don't really like understand it. To the point where like I almost consider it like a definition than like an actual logical statement that you could understand intuitively as a human. I see it more as like a rule. Anyway. The Curry-Howard isomorphism. I know Curry was Haskell Curry. I don't know who Howard was though. It's a direct deep connection between mathematical logic and computer programming. Oh, that's right. No, I've heard of this. I've heard of the Curry-Howard correspondence, but not the isomorphism. But I guess it's the same thing. A direct deep connection between mathematical logic and computer programming. At its core, it says that propositions are types and proofs are programs. Named after Haskell Curry and William Alvin Howard. Propositions are types. You could say that. This principle shows that writing a computer program and proving a mathematical theorem are the exact same activity viewed through two different lenses. Sure. But yeah, aka the Curry-Howard correspondence, it states that writing a computer program and proving mathematical logic is identical. Are the same activity, and that types are propositions, while functions, no, proofs, while programs are proofs. Weird. Next is a type, like, I've heard about it, but again, I don't really understand how it's true, if it even is, or if it's more of like a philosophical statement that you may or may not agree with. Next is a type that corresponds to a singleton set. A singleton set is a type that has only one possible value. This value just is. You might not immediately recognize it as such, but that is the C++ void. Think of functions from and to this type. A function from void can always be called. If it's a pure function, it will always return the same result. Here's an example of such a function. Yeah, a type with one possible value. Until it's impure and thus non-deterministic. But yeah, pretty much, right? If its input is unit, that it simply maps unit to one result, which is pretty cool. You might think of this function as taking nothing, but as you've just seen, a function that takes nothing can never be called because there is no value representing nothing. I see. So like from like a mathematical notion, it's like the function. Like I have to go from something to something, right? Right. So thinking about it in this manner allows me to mathematically express that a function taking no arguments is actually mapping a unit type to a fixed, to a set of one, to a singleton set. If there were truly no arguments, then I would have nothing to morph, right? So, okay. So what does this function take? Conceptually, it takes a dummy value of which there is only one instance ever, so we don't have to mention it explicitly. In Haskell, however, there's a symbol for this value and empty parentheses. So by a funny coincidence, or is it a coincidence, the call to a function of the void looks the same in C++ and in Haskell. Yeah. Also, because of the Haskell's love of terseness, the same symbol, this unit, is used for the type. Yeah. The constructor and the only value corresponding to a singleton set. So here's the function in Haskell. Funny thing is, though, in Haskell you select just set values, but mind you, no. Yeah. No, yeah. Like a variable is also a function. But it's like calling a variable is like calling the variable's getter, you know? And the getter just happens to access the variable directly. Right? It's kind of interesting. The main difference, though, is like a variable is addressable. Like a variable is such that I can address it. Because like it has an address. Because like it stores something. So like while the interface is a getter and a setter, like those getters and setters are accessing some data, whereas like a typical function isn't getting or setting anything. It's just performing a calculation. So that's why I still have a distinction between variables and functions in my language, even though I know Haskell doesn't really. Haskell variables are more just like, well, like these functions that take it like an implicit unit value. I do wonder though. Is there a way to model them as functions anyway? Not really, right? Not to mention that like, the functions themselves are addressable, but I mean, well, when you pass around function pointers, right? So like they exist. They're not purely abstract. Although some functions may not be addressable. Some may only be addressable if I require that they are addressable, and otherwise they are simply inlined. Also, because of the Haskell's love of terseness, yeah, the first line declares that f44 takes a type pronounced unit into the type integer. The second line defines f44 by pattern matching the only constructor for unit, namely this, and producing the number 44. You call this function by providing the unit value. Actually, let me just ask real quick in the Discord server. The lines of self-mute and self-read. Effects and functions and methods that either of these is able to be self-mute, right, and self-mute. Alright, so by the way, has anyone considered unifying pattern match syntax with their function arguments syntax. I stumbled across this while designing functions for true, and I realized that Haskell does actually that is what Haskell does for its functions too. Like, suppose I have underscore x as my bind syntax. Which binds the value, which binds the input, which binds the argument to a variable x. I'll do at x to get more explicit. Whereas then I can do stuff like this. Print line x plus y. I don't know. Just give like a less confusing example. It would need to be exhaustive though, right? It's also it also reminds me of how pattern matching kind of works in C++ via the visitor pattern, where you just specify a bunch of function overloads. The main limitation there is that C++ functions cannot bind to values. Unless there's some funky template magic. I'm not aware of. Also, I'm specifically referring to lambdas, which I have in the form args body, which you can see above, and defines a product type. I'm almost wondering, like, do I even need... No. Like for if statements, you know? Yeah, I just realized actually, hold on. Like for my if statements... this might also make me rethink how my if statements work. Since here, since they could be written as if condition is, no, if foo is lambda. If foo is lambda. Which then makes me wonder if there's a better, if there's a more natural structure for this. Maybe something like when like when, no, not when, like match, even like match foo with this to this, but like it's a function, right? Like it's interesting because you can just call the lambda on the function. Lambda equals, okay, let lambda equal some lambda if foo is lambda. Lambda handles both the match and resultant execution and resultant expression. Yeah, so like I mean the most obvious one is just let lambda and just call lambda foo. Issue is though it's on like an if is true kind of basis, you know? If it's non-exhaustive, then it will do nothing. Right? Must be exhaustive then. Unless it should return an option T instead. Yeah, this is interesting. Good. What even inspired that? What? What inspired that? What did I see that made me think of that? I don't even know. Okay, wow, I forgot. Notice that every function of unit is equivalent to picking a single element from the target type. In fact, you could think of f44 as a different representation for the number 44. Yeah, this is an example of how we can replace the explicit mention of elements of a set by talking about functions and arrows instead. Functions from unit to any type A are in one-to-one correspondence with the elements of that set A. Can I just say, Haskell is such an amazing language? Like, it has its flaws, sure, but like, the commitment it has to kind of like actually following mathematical models, and like the fact that it does it damn well, potentially better than any language, well, definitely better than any language I've seen so far. I haven't looked at like Agda and Lean, and like Ada, maybe those are like a step up, but got a bit sidetracked and decided to order a USB extender thing. It's nice because it comes with 7 different plugs. Mostly just because right now my laptop only has 2 ports, and I'm using it for my camera and for my keyboard. So I can't, like, it's the reason I don't like have like my microphone plugged in, because I don't have a port for it, and I have nothing to plug these into either, unless I unplug my camera or keyboard, which I don't really want to do. So yeah, that's the whole thing. But apparently Amazon Prime is free for students for 6 months. So that's awesome. 6 months, like half a year of free Amazon Prime shipping. And I get Prime Video, which is probably the only other thing I use it for. There's Amazon Prime Music, but it's not unlimited. Like you can't select specific songs without paying for the upgraded tier. And there's Prime photo storage, but the issue is they trap you by basically having you upload all like your memories and stuff, and then when your thing renews and you realize you have nowhere else to put them, then you feel pressure to subscribe and keep subscribing. Keep in mind though, like it's literally I think it's £9 a month for regular people, and it's £4.50. It's half the price for students aged between 18 and 24. So like, it's not even expensive. Honestly, it's kind of crazy. I would use the photo service, but I want to self-host some kind of storage anyway. But yeah, that's just kind of interesting. Anyway, back to this. So, yeah. Right, category theory. Where was I? Right, so in fact you think of f44 as a different representation for the number 44. It's an example of how we can replace explicit mention of elements of a set by talking about functions instead, or arrows. Functions from units to any type A are in one-to-one correspondence with the elements of that set A. I was just thinking as well, when it comes to having addressable variables in a public API, why not have like a getter, a setter, and a referencer? You know? Functions from unit to any type A are in one-to-one correspondence with elements of that set A. Yeah. But what about functions with a void return type, or in Haskell with the unit return type? In C++, such functions are used for side effects, but we know that these are not real functions in the mathematical sense of the word. Yeah. A pure function that returns unit does nothing. It discards its argument. Oh, right, yeah. So Haskell purity is not just for determinism, but also for not doing side effects. Mathematically, a function from a set A to a singleton set maps every element of A to the single element of that singleton set. For every A, there is exactly one such function. Here's this function for integer. Yeah? Yeah. You give it any integer, and it gives you back a unit. Some languages have this as like a feature, right? Where like you can just do any like there's a conversion to unit for everything. In the spirit of terseness, Haskell lets you use the wildcard pattern, the underscore for an argument that is discarded. This way you don't have to invent a name for it, so the above can be written as this. Okay, learning Haskell as you go, although I already know Haskell, so notice the implementation of this function not only doesn't depend on the value passed to it, but it doesn't even depend on the type of the argument. Functions that can be implemented with the same formula for any type are called parametrically polymorphic. The same formula for any type. Okay, you can implement a whole family of such functions with one equation using a type parameter instead of a concrete type. What should we call a polymorphic function from any type to unit type? Of course we'll call it unit, yeah. Template class T, void unit T, yeah. Next, in the typology of types is a two-element set. In C++ it's called bool and Haskell predictably bool. The difference is that in C++ bool is a built-in type, whereas in Haskell it can be defined as follows. The way to read this definition is that bool is either true or false. In principle, one should also be able to define a Boolean type in C++ as an enumeration. But C++ enum is secretly an integer. Yeah, the C++ 11 enum class could have been used instead, but then you would have to qualify its values with its class name as in bool true and bool false, not to mention having to include the appropriate header in every file that uses it. Pure functions from bool just pick two values from the target type, one corresponding to true and another to false. Functions to bool are called predicates. Functions to bool are called predicates. Right? For instance, the Haskell library data.char is full of predicates, like is alpha or is digits. Okay, in C++ there's a similar library that defines, among others, is alpha and is digit, but these return an int rather than a boolean. Yeah, the actual predicates are defined in standard C type and have the form C type is alpha C, C type is digit C. Not really fair to call it C++. I mean, like, it is in C++, but I believe this is a product of C, where C did not have booleans. So, like, it's not really, like, C++ code in particular, but, like, it is, yeah, it is in C. Right, so predicates. I mean, I kind of already knew that, but it's interesting that they have there's like a special name for these functions. I wonder if I can have that work as well in my language. Like for predicates, I feel like predicates can be expressed as types, right? Or like type conversions. To be fair, all functions can be type conversions. Challenges: define a higher order function or a function object. Memorize in your favorite language. Sorry, that's actually sticking with me now. Have a morphism from type A to type B. Yeah, but side effects. Define it. Okay. This function takes a pure function f as an argument and returns a function that behaves almost exactly like f, except that it only calls the original function once for every argument. Okay. Try to memorize a function from your standard library that you normally use to produce random numbers. Does it work? It should work. Most random number generators can be initialized with a seed. Implement a function that takes a seed, calls a random number generator with that seed, and returns a result. Shit. Why wouldn't it work? I don't understand. Which of these C++ functions are pure? Try to memorize them and observe what happens when you call them multiple times. Memorize and not. Oh, no, yeah, no. Yeah, no, you can't memorize it, because it's non-deterministic. The factorial function from the, yeah, whatever. How many different functions are there from bool to bool? Can you implement them all? Like pure functions? I mean, it's potentially infinite, if I just do like a side effect, but assuming that this means pure functions, there's two, right? No, there's four? True to false, false to true, sorry, true to false, false to false, true to true, false to true. Although really it's just two functions. There's the identity function, and then there's the flip function. Draw a picture of a category whose only objects are the types void and bool, with arrows corresponding to all possible functions between these types. Draw Wait. Draw a picture of a category whose other objects are the types void, unit, and bool, with arrows corresponding to all possible functions between these types. Label the arrows with the names of the functions. Sure. Do I have like a paint thing? Like a draw? Nope. What's a good Linux draw app? Like paint app? Critter, GIMP, Pinter. I've heard of Critter. I mean, I don't do anything crazy. This is team. That's cool. Like a meetup. What if I just want something quick and simple, like Microsoft Paint is? Penta. Okay. Yeah, there's a non-zero chance that I get a virus from the AUR now, which is kind of annoying, but oh well. Next. It has a nicer interface in Microsoft Paint, that's for sure. Can I zoom in? Yeah. Right, so we have... Never mind, it is pixelated. Type, normal... What? Funky. Aliasing on. Off. Oh yeah. I think I prefer off, right? Yeah. Okay, types, void, unit, and bool. Category. Okay, so here we have a category. Okay. Try that again. Here we have a category. Like that, okay. It's called category, whatever. And we have void, unit, and bool. Okay, so there are these objects, void, unit, and bool. Okay. And we need the functions. Okay, so we have, first of all, we have these ones, right? So we have the entity function, we have bool, which is the entity function, and we have unit, which is the identity function. So that's the first thing. Then for void to, there's no morphism from void to units, right? But I assume there is one for units of void. So I'll go this way. And same for this one. But voids cannot go to any of these. Then there is a morphism from bool to unit with the names. I don't know what the names are. Yeah. And there, I guess, could exist. No, is there a morphism from unit to bool? Not really, right? Like, you could do. I guess like two things. True, and then another one, false. And this is just like, I don't know, discard. And this is like delete almost. There you go. Let's save this beautiful creation. Give it a name later. Put it in my documents. Quality, max quality, please. Okay. Chapter 3. So before going any further, let's revisit these notes. I don't know which chapter is which. Page 13? Yeah, okay. So, category theory is about composing arrows. No, that's the previous last one. But yes? Yes. Wait, I guess that was already said, wasn't it? Like here, composition is the essence of programming. So types are about composability. Category theory is like composing arrows. Judiciously. Definition, judiciously. Did I spell that right? No. I know I didn't. Judiciously. Meaning to act with good judgment, wisdom, or care. Okay. Testing is a poor substitute for proof. Yeah, I mean, I don't like have any thoughts about that. It just kind of sticks with me for now, and I could come back to it later if I wanted to. What are types? Oops. Definition, stickler. In set. Okay. So there exists a category of sets called set, in which the objects are sets and the morphisms are functions between those sets. Right? From my understanding, this is where most, I don't know, pre-university maths resides. No, not like pre-university, like academia. Like you wouldn't really go past this unless you're going like deeper into maths, in like a math heavy subject. I could customize description, but I don't know. Can I be bothered for now? The halting problem. Yeah. The halting problem, the infamous halting problem. Apparently states that it is impossible, well, it is undecidable for a computer to prove whether a given function is terminating or non-terminating. And this is a problem for proof systems in programming language, in programming languages. No. And this is a problem for static analysis tools, for programming language static analysis tools. Why does it add that? Where does that come from? Okay. Is that the bottom value means a condition which does not terminate and is represented by the symbol which can supposedly also be written as that. Oh, wait, that's weird. It actually has like a. That's funny. Damn, I didn't know there was a ligature for that, which can also conventionally be written JetBrains Mono. Some fonts even have it as a ligature. Cool. Should I use this in my language? Probably not. I'm not all for like special symbols, but I mean there's ligature for it. Can't be that bad, can it? Speaking of which, actually, what are all the JetBrains Mono ligatures? Just kind of get my brain going. Where can I see the full list here? There's dash, triple dash, equals, not equals. And there's triple and equals, yeah, plus 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 plus. Plus 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 is crazy. Bunch of question mark stuff, question mark colon, question mark dot, question mark equals. Whatever that is. For some reason, there's like, oh, these ones too. To be fair, these ones are more for like file trees. Oh, I guess this one is actually for the symbol special. Funny enough, they had like hashtag things, but no hashtag equals, which is a shame. Hashtag question mark, hashtag underscore, what? Well, no, there is hashtag equals. It's just not, for some reason they didn't, what? There's hashtag equals, but they didn't go for like actually connecting it. And yet they have this, that's funky. There is these. I do wonder about using these for like product types and sum types. But I don't know. It's like it's easy to confuse them with addition and multiplication. I don't like overloading the meanings. Got these arrows. I use some of them, but I guess I could also use some of the other ones too. I just don't know what I mean. Like, I don't want to add too many symbols anyway, though. And I definitely not just add symbols for the sake of adding symbols. This arrow is kind of funky though. These brackets, okay. Good to know that that's an option. Yeah, you got the piping. Huh, dot equals. Dot equals. I don't know. Some comment stuff. And underscore? Why is that a ligature? Anyway. Okay. Functions that may return bottom are called partial, as opposed to total functions, which return value results. Yeah. Functions that may not terminate, and thus return bottom, are called partial. And those which are guaranteed to terminate are total. Bona fide, meaning in good faith. Okay, why do you need a mathematical model? 2.4. Exegesis. Exegesis. What a strange word. Exegesis. Consider reading this. Nils Anderson, John Hughes. Wait, morally correct. It's a bit funky. Yeah. That means we do reason about faculty right, and we should bring a position in our heads. Copy that part as a quote. And my thoughts on this were this. Amenable. Oh, so much vocab. Amenable. exorbitant. Exorbitant. .6 examples of types. I'm aware that I could probably automate this with like AI or something, but it is good to just review the notes as well one more time. Types or sets. Yeah. So this is if we look at it again. You can find a function that's void, but you can never call it. To call it, you will still have to provide a value to void, and there just isn't any. Yeah. Curry-Howard isomorphism. A dodge. Similar to aphorism. A short saying because it goes in real life. Okay. If it's a pure function, it will always return the same results. Yeah. I luckily wish that like my mouse would always be centered on the screen, like always, no matter what. But I know that there's some scenarios where I don't want that, so. Hello. Oh, okay. Functions of bool are called predicates. So a function that returns a bool is can be called a predicate. There was something else about that. I wonder if therefore booleans can be treated specially in a language's type system. Like verse, verse uses them especially with logic-based programming. Well, for example, yeah. Okay. Challenges. And then I can input my image here. How do I upload? Control U? No. That goes up to the top. Just open this. Oh, it's called unsaved image. I thought it was unnamed. That's weird. Category theory for programmers. Exercise 2.7 point what? 0.6. Get load. My attempt at question at challenge 6. The size. Alright. Cool. That's it, right? Yeah. So the next thing to do would be to go through these notes and turn them into, well, kind of organize them. So like turn some things into atoms, add some things to my cheat sheet. But for now, I would rather just move on. Oh, well, these stack. That's annoying. Right, so where are we? Up to 1, 2, 3. Monoid. Okay. Have a look. Categories great and small. You can get real appreciation for categories by studying a variety of examples. Categories come in all shapes and sizes. Appreciation. I assume that doesn't mean understanding. They come in all shapes and sizes and often pop up in unexpected places. We'll start with something really simple. The most trivial category is one with 0 objects, and consequently 0 morphisms. Right. So a category without objects has no morphisms, right? Because morphisms are between objects. I do also know that a morphism between categories is a functor. It's a very sad category by itself, but it may be important in the context of other categories. It's kind of weird then that like Haskell has functors, despite not having categories. But maybe I misunderstand, because like Haskell has the category of set, or Hask, right? So, unless like monads are a category in which Hask can like reside or something. I don't really know. It's a very sad category by itself, but it may be important in the context of other categories. So is there a name for the like I assume it's the empty category now, but it may be important in the context of other categories. For instance, in the category of all categories, yes, there is one. If you think that an empty set makes sense, then why not an empty category? Right, like the set of all sets. It's like, what is the empty category? Unempty category in category theory. My thumb's tweaking. I wonder why. Because I don't know. Richard is 0. Right, so yeah, so it is unique. Okay. It's the initial object in the category of all categories, named cat. For any category C, there is one and only functor from the empty category to C. Right. It's like the unit category though, right? Yeah, it's like the void object almost. It's rather interesting. Yeah. This is denoted as category 0. Okay. The category of all categories. Denoted as I forget what I use. Is it bold? Luckily, I do actually have this as a note. What's it called? Latex. Math BF for boldface. Is it boldface though? I think it is. Yeah, it'd be cool if I had like a proper renderer as well in my notes. I guess Obsidian could maybe do that. If you think that an empty set makes sense, yeah. Simple graphs. You can build categories just by connecting objects with arrows. You can imagine starting with any objective graph and making it into a category by simply adding more arrows. Right, so but there are rules, right? Like the identity arrow. First add an identity arrow at each node. Then for any 2 arrows, such that the end of one coincides with the beginning of the other, so composable, add a new arrow to serve as a composition. Every time you add a new arrow, you will have to also consider its composition with any other arrow, and itself. You usually end up with infinitely many arrows, but that's okay. Really? Yeah. I mean, I guess you know, if there's A to B and B to A, then you have A to A. But would you really include that? Probably not. Another way of looking at this process is that you're creating a category, which has an object for every node in the graph. And all possible chains of composable graph edges as morphisms. You may even consider identity morphisms as special cases of chains of length 0. Graph theory. Such a category is called a free category. Wait, there are free monads as well, but I don't know what that is. It's an example of a free construction, a process of completing a given structure by extending it with a minimum number of items to satisfy its laws. halos of a category. Ah, okay. We'll see more examples of it in the future. Yeah. I believe I've come across this as in the free monad or free monoid, which, if I remember correctly, are that which satisfies its minimum number of rules. It's minimum rules and nothing more. Okay. Orders. Right, yeah, order. And something completely different. A category where a morphism is a relation between objects. A category where these are examples, right? A category where a morphism is a relation between objects. The relation of being less than or equal. Oh, what? So every morphism is just a relation. Let's check if it is indeed a category. Let's check if it indeed is a category. Do we have identity morphisms? Every object is less than or equal to itself. Check. Do we have composition? If A less than or equal to B and B less than or equal to C, then A less than or equal to C. Check. Is composition associative? Check. Because you have relations in set theory, right? A set with a relation like this is called a pre-order. So a pre-order is indeed a category. A set with a relation like this is called a pre-order. What? I haven't heard that before. Every pre-ordered set is a pre-ordered class. There are classes in maths, like OOP. A pre-order is indeed a category. Okay. You can also have a strong relation that satisfies an additional condition that if A less than or equal to B and blah blah blah, then A must be the same as B. That's called a partial order. Why? Finally, you can impose the condition that any two objects are in a relation with each other, one way or another, and that gives you a linear order or a total order. Yeah, what? I know partial ordering from like a set can precede or relate to one another. Like, I know like you have partial equality, for instance, and partial ordering, partial ord in Rust, right? Like for floats, I think, are partial ordered. But I mean, I don't think they are partial ordered because of NaN, not number. Right? Well then, what's pre-order? Just one that has associativity laws. And total order is like, yeah, ints. When any two objects are in relation with each other. Right. Okay, no, I understand actually. Let's characterize these ordered sets as category. I mean, that's all, yeah. I mean, I knew that. But pre-order now. Let's characterize these ordered sets as categories. A pre-order is a category where there is at most one morphism going from any object A to any object B. Another name for such a category is thin. A pre-order is a thin category. Right, I've heard about this before. In set theory, in my lessons, there was like a term to describe a relation, I think, such that there is at most one. Let me just check if I have any notes on that, because I don't know. Relation. A relation is antisymmetric when x are y and y are x imply x equals y. So for all y, x, no, for all x and y, x relation y and y relation x implies that x equals y. Closure, constellation, partial. Oh yeah, here you go. Partial order, total order. Huh. I guess I knew this? I just completely forgot about this. I forgot I learned about this. So it was anti-symmetric. It's a partial order. But there's also an equivalence relation. Right, so we didn't cover pre-order though. It's interesting. At most one morphism, going from any object A to any object B. So like A is less than B, but like you can't say that B is less than A, right? Right, so this category is total order, right? So then it's all pre-order. A set of morphisms from object A to object B in a category C is called a Hom set, written as CAB, or Hom CAB. I've seen this before actually. Okay, hold on. A pre-order is a category where there is at most one morphism going from any object A to any object B. A set of morphisms from object A to object B in a category C is called a Hom set. A to B. Okay, what's called a Hom set? So every Hom set in a pre-order is either empty or a singleton. Yeah, okay. That's a nice way to talk about it, I guess. That includes the Hom set CAA. A to A. But that's the, so the Hom set, so CAA would be the identity, no? The set of morphisms A to A, which must be a singleton containing only the identity in any pre-order, yeah? Wait, but what if there isn't an identity function then? Like, is less than a category? I assume no, because it must be less than or equal to, right? You may, however, have cycles in a pre-order. Cycles are forbidden in a partial order. But what does cycle look like? It's very important to be able to recognize pre-orders, partial orders, and total orders because of sorting. Sorting algorithms such as quicksort, bubble sort, merge sort, etc. can only work correctly on total orders. Partial orders can be sorted using topological sort. Right, I've heard of topological sort, but I don't know what that is. But don't know what it actually is. Okay. Cycles. Monod is set. A monod is an embarrassingly simple but amazingly powerful concept. I feel like this is like a lot of category theory. It's the concept behind basic arithmetics. Both addition and multiplication form a monoid. Monoids are ubiquitous in programming. Ubiquitous. I know what it means. No, I know the word, but I can like kind of infer the meaning. Present, appearing, or found everywhere at the same time. Impossible to escape. Right. Meaning appearing everywhere, impossible to escape. Feeling impossible to escape. Yeah, that's not how I usually like think about it. Like friends are ubiquitous in modern society. I think more about it more like they go hand in hand, or like they, like you cannot have X without Y, which I guess that's what it says, but in a different way. So there's an official Tonia logo. They show up as strings, lists, foldable data structures, features in quick programming, features? I don't know what features are, bro. Events and functional direct-active programming, and so on. Oh yeah, events are also a thing. Event-based programming. What I can say from what I know as a monoid being is that a monoid has like 3 rules, I think, which is it has the not the identity function, but like the identity value kind of. So like it's the the identity value for that operation, such that if I do the operation with that value, nothing changes. So for addition, it's 0, because if I add 0, nothing changes. Or if for multiplication, it's 1, because if I multiply by 1, nothing changes. Division is 1, subtraction is 0. For like concatenation with like lists or strings, it'd be the empty string or empty list, right? Type thing. Traditionally, a monoid is defined as a set with a binary operation. Does it have to be a binary operation? All that's required from this operation is that it's associative. Yep, right. I guess division isn't a monoid then. Because with like addition, like 1 plus 2 and 2 plus 1 are the same. Or I guess the official rule is like 1 plus 2 plus 3 is the same as 1 plus 2 plus 3. Whereas with division, that's not the case. And then there's one special element that behaves like a unit. Oh, that's right, the unit value with respect to it. For instance, natural numbers with 0 from natural numbers with 0. Oh yeah, and you also specify the type. So there's the type, there's the unit value, and then there's the actual the actual binary operation, of course. That must be associative. For instance, natural numbers with 0 from a monoid under addition. Yeah, so this is how you describe it. Like you don't say that natural numbers are a monoid. You don't say that 0 or addition is a monoid. No, you say natural numbers with 0 form a monoid under addition. So like it's like all of those together as like one bundle. You can't have a monoid like just partially defined. Yeah, so like this verbal notation is very important to recognize, as it shows that a monoid isn't that it's not that a natural numbers are a monoid or addition is a monoid, but rather that a monoid is formed under addition on natural numbers with a unit of 0. In other words, you can skip parentheses and yeah. The neutral element is 0 because the second equation is redundant because addition is commutative. Oh right, no, that's different. So commutativity is all part of the definition of a monoid. Okay. See, that's something that I mix up sometimes. So, for me to keep in mind, since I sometimes confuse it, associativity and commutativity are different things. So division then is not commutative, right? Or rather, division. Wait, I mean division isn't. Like division, let's say with natural numbers. Not to mention that the result goes to a different set for division. Because like 3 divided by 2 is not a natural number either. Subtraction though. Subtraction also isn't commutative, right? Commutative. Nor is it associative. Like 1 minus 2 minus 3 is different from 1 minus 2 minus 3, right? 1 minus 2 minus 3, so 1 minus 2 would be negative 1, minus 3 negative 4. Is that equal to 1 minus 2 minus 3? No, because that'll give you 2. So, yeah. So like there's a formal definition of a monoid. If I go to Wikipedia, you can probably find it. This is abstract algebra. Yeah, that's like another thing. Abstract algebra. I don't know. I don't know much about abstract algebra. I just know that like it's yet another thing that's under category theory, in the same way that like set theory is and type theory is, and graph theory, I guess. Yeah. So like this is the formal definition. So yeah. So it's M, me, eta. In a monoidal category, which means you have the category C, you have the identity, I guess, and you have product type with 2 morphisms. Right. So the 2 morphisms are me and eta. It's called multiplication, yeah, which is kind of funky. So there's a morphism such that m multiplied by m is m. Thing is though, like this isn't the product, so it's kind of weird. I mean, for eta you have I to m called unit. Then here's a diagram, and there's 3 different kinds of diagrams apparently. But then there are these morphisms, rho and lambda. They commute. One is the identity morphism, as there. I is the unit element, and A, alpha, lambda, and rho are respectively the associated, the left uniter, and the right uniter. Boy, there's so much here, what? So, for sets. Right, to be fair, this is a monoid as a set, right? But like that's in set theory. There's a more general term for a monoid. Okay. Yeah, so I guess like functors and monoids and like all that kind of stuff do exist in like set theory anyway. They're just like more concrete than the general abstract term of a category, such that Haskell gets away with using it. Kind of. I swear there was something a bit more concrete than this. Can't remember. So M is an object. The thing is, I don't know if it's a binary operation then at that point. Like, what I get from this is that me is a morphism that takes a type M and another type M, and then returns an M, right? So like it is the product type. So like it's a tuple, so 2 values of type M, or that are of the object M, I guess, because this isn't type theory, and then returns something that's also in the object M. But like objects aren't categories, right? Like is a set an object? Sets are objects. Yeah. Yeah. So that fits into the object M, whatever that means. So like there's the binary operator, and then you have eta, which is the identity to M. Now I don't know what that means. I think I is defined individually then, potentially. But that also returns something in the M category object. Kind of. But yeah, that's called unit. And then you have these. Now, I don't know what it means to take the multiplication of a morphism with 1. Yeah, so I understand this at least, and this. So me takes 2 values and produces 1, right? So like, let's say that these objects here were 5 and 3, and I was multiplying them, I would get 15. Because me would just multiply them and you get 15. That's like a concrete thing there, right? And let's continue with that. So 5 and 3. If we take, so this is the, well no, because it's me that does it, right? So let's say we have 15 and then we have I, so let's say I is 1, right? Then you have the unit function, or unit morphism, with 1. I don't know what that means. 1 is the identity morphism of M. Identity morphism, so does that mean that it just returns itself? And then what does that mean if you cross-fit with 1? No, 1 is the identity morphism. So, what? How do I get M from that? It transforms I to M. And the order matters. Oh. Okay, my guess is that if you apply a tuple to a tuple, then it goes like individually. So like here it's applying eta to I. This is just pure guesswork. Eta to I, so then I becomes M, right? So they get M, and then 1 is the identity morphism, so then M is just unaffected. So then here as well, it applies 1 to M here, and eta to I, so then you get M, and then eta to I produces M, so then you get this as well. And then you have rho and lambda, which both, I don't know, somehow get here. Yeah. One day I'll be able to understand that. The second equation is redundant. Yeah. For instance, string concatenation is not commutative, and yet it forms a monoid. Yeah. Why is that? Like A plus B plus C is equal to A plus B plus C? Yeah. I mean like A join B join C. The neutral element for string concatenation, by the way, is an empty string, yeah? It can be attached to either side of a string without changing it. In Haskell, we can define a type class for monoids, a type for which there is a neutral element called mEmpty, and a binary operation called mappend. Class monoid M. Yeah. Why is it append? That's weird, like, I know the strings from a monoid, but do addition and subtraction also from a monoid in Haskell? Like appending 5 to 3 in like addition or multiplication. The type signature for a 2-argument function might look strange at first, but it'll make perfect sense. Yeah, currying. Okay, the latter interpretation may be emphasized by adding parentheses, which are redundant because arrow is right. Yeah, okay. Notice that in Haskell there is no way to express the monoidal properties of mEmpty and mappend. The fact that mEmpty is neutral and that mappend is associative. Right, yeah. So like they're fake, basically. it's the responsibility of the programmer to make sure they are satisfied. So you could violate the rules. I don't really understand that. Like, I don't get why it can't just check the rules statically. I mean, like, I guess how would it, right? Like, it would have to use concrete examples to test it. You can't really, like, can you prove it without concrete examples? I don't even know if you can. Haskell classes are not as intrusive as C++ classes. Yeah, I have no idea, actually. Is it even possible for us humans to prove it by hand? Sorry, to prove that... Well, yeah, to prove a monoid by hand. Or is it unprovable and only testable with random concrete values? Haskell classes are not as intrusive as C++ classes. When you're defining a new type, you don't have to specify its class up front. Hold on. I guess I can test this to an extent. Haskell online. Let's do... Like, I can do... hold on. Plus plus is just for strings, right? But this is like a general operator, I think. Like, if we do... print $sign plus plus low on that. That works. I believe it's this operator as well, which is for appending. So can I print 5 append 3? No. Can I define it? Instance monoid int where mempty equals 0 and append equals plus. Also, like, this is like on the type, right? Like a monoid int. But like, there's like, if both multiplication and addition are monoids, how do I like just disambiguate between? Well, I guess by using different operators, right? No instance for similar group int. Right, so I need to define that. Okay. Haskell classes are not as intrusive as C++ classes. When you're defining a new type, you don't specify its class up front. You are free to procrastinate and declare a given type to an instance of some class much later. As an example, let's declare string to be a monoid by providing the implementation of mmempty and mappend. Here we have reused the less concatenation operator because a string is just a list of characters. A word about Haskell syntax: any infix operator can be turned into a 2-argument function. Yeah. Notice that arguments to a function are not separated by commas or, yeah, okay. It's worth emphasizing that Haskell lets you... How is that the hardest thing to get used to? Conceptually, this is different than expressing the equality of values produced by functions, as in... The form translates to equality of morphisms in the category Hask or set if you ignore bottoms, which is the name for never-ending calculations. Ha! Funny how it defines that later. Again, such equations are not only more succinct, but can also... Yeah, okay. The latter is called extensional equality, and states the fact that for any two input strings, the outputs of mappend and plus plus are the same. Oh yeah, mappend is also just a word, isn't it? Mappend, hello. Yeah, I mean, this isn't valid. tragically. But this works too, right? Yeah. I don't believe you can check equality, though, on functions. Like, I can do h equals h. True. But, like, I can't do append equals this operator. Yeah. Maybe if I surround it. No. So like I could have a function exclamate from string to string. That simply takes, well, that's equal to append. I think like this, append exclamation mark. So I can do exclamate hello. Parse error on this. Yeah, what's actual syntax? Is it like this? Yeah. Pretty cool. Or just, you know, plus plus. But yeah, you do have to appreciate the succinctness, and I do wonder if I should support this in my language. But I'll see down the line what is like really possible without ambiguity. Since the values of arguments are sometimes called points. Since the values of arguments are sometimes called points, as in the value of f at point x. Oh, okay. This is called point-wise equality. Function equality without specifying the arguments is described as point-free. What? Incidentally, point-free equations often involve composition of functions, which is symbolized by a point. So this might be a little confusing to the beginner. So extensional equality. They're equal if they have the same external properties, behavior, or components, regardless of their internal definition. Right. Right. The requirement is that the inputs is that the results should be the same for the same inputs, but the implementation does not matter. Now that's actually really important, because for my language, I probably will have a way to also check if two API are equal, but with like different implementations. That'd be quite interesting, wouldn't it? So like it means that like well no, it's not like it's not type equality, is it? Yeah, I don't know, whatever. These points though, what? The value of f at point x. But those are arguments. F is a result. Oh, at point x. I see. Yeah, like a graph. Okay, point-wise equality. Interesting. Yeah. Function equality without specifying the arguments is described as point-free. Yeah. Okay. The closest one can get to declaring a monoid in C++ would be to use the C++20 standards concept feature. Yeah, I mean, it's nice that things are getting better in C++, but I feel like they're just hard limits. Struct mmempty mappend t equals delete. Concept monoid requires mmempty m value has to be the same standard same as m. Wait, what? What's the value of a struct? I haven't used much concepts myself, so requires mm. Mappend standard same as m. Is that like the type? I can't tell. It's in braces as well. The first definition is a structure meant to hold a neutral element for each specialization. How? Why is it a struct? The keyword. Oh, it's duck typing. So just a static value. Fair enough, I guess. Yeah, I was confused because like colon value is like an actual thing in some cases. I think some standard library things. The first definition of the structure, yeah, the keyword delete means that there is no default value defined. It will have to be specified on a case-by-case basis. Interesting. I've never used it like that, yeah, delete like that. Probably because you're not really meant to. At least like originally, hence it's called delete. Similarly, there is no default from append, for mappend. Right, I mean, there's no delete here though, but okay. The concepts. Yeah. I'm confused. Why doesn't this include delete as well? I think that makes things a bit more clear. The concept monoid tests whether there exists appropriate definitions of empty mappend for a given type M. And notation of the monoid concept can be accomplished by providing appropriate specializations and overloads. Yeah. Pretty cool. Does it work though? I wonder how far you can go with this in C++. Because like, is this not the same as Haskell approach? Like in terms of like actual functionality. Obviously a lot more verbose, but monoid as a category, that was the familiar definition of the monoid in terms of elements of a set. But as you know, in category theory, we try to get away from the sets and their elements and instead talk about objects and morphisms. So let's change our perspective a bit and think of the application of the binary operator as moving or shifting things around the set. Okay. Yeah. For instance, there is operation of adding 5 to every natural number. Imam 0 to 5, 1 to 6, 2 to 7, and so on. That's a function defined on the set of natural numbers. That's good. We have a function and a set. In general, for any number n, there is a function of adding n, the adder of n. How do adders compose? The composition of the functions of the as5 with a function as7 is a function as12. Yeah. So the composition of adders can be made equivalent to the rules of addition. That's good too. We can replace addition with function composition. But wait, there's more. There's also the adder for the neutral element 0. Adding 0 doesn't move things around, so it's the identity function in the set of natural numbers. Instead of giving you the traditional rules of addition, I could as well give you the rules of composing adders, without any loss of information. Notice that the composition of adders is associative because the composition of functions is associative. And we have the 0 adder corresponding to the identity function. Right, so like shifting it is interesting. Like we're shifting between values, not constructing new values, I suppose. An astute reader might have noticed that the mapping from integers to adders... Wait, what? Adders is... Wait, what? For any number n, there's a function of adding n, the adder of n. Okay. The mapping from integers to adders follows from the second interpretation of the type signature of mappend. It tells us that mappend maps an element of a monoid to a function acting on that set. Now I want you to forget that you're dealing with a set of natural numbers and just think of it as a single object, a blob with a bunch of morphisms, the adders. So like +1, +2, +3. A monoid is a single object category. In fact, the name monoid comes from Greek mono, which means single. Wait, single object category. Every monoid can be described as a single object category with a set of morphisms that follow appropriate rules of composition. String concatenation is an interesting case because you have a choice of defining right dependers and left dependers, or prependers if you will. The composition tables of the two models are mirror reverse of each other. Oh yeah, okay. You can easily convince yourself that appending bar after foo corresponds to prepending foo after prepending bar. You might ask the question whether every categorical monoid, a one-object category, defines a unique set with binary operator monoid. What the hell? Everyone in the UK got this government-issued warning about wildfires, but I got it like a few hours ago. I don't know why I said it twice. That's awesome though. Also, it's like 11 PM. Why would the government issue a warning at 11 PM for the well, like when people are sleeping? I mean, it is a Friday, but like still, jeez. So I remember when it came a few hours ago, I thought there was like a missile strike or something. Because the last time I got such a notification was in Qatar, when there was bombing from Iran. So like, yeah, I'm glad it's just wildfires. Well, not even just like a warning about not purchasing barbecues and setting things on fire. The composition tables of the two models are mirror reverse. Yeah, you might ask the question whether every single categorical monoid, a one-object category, defines a unique set. What? Categorical monoid is another term. Defines a unique set with binary operator monoid. Set with binary operator. It turns out that we can always extract a set. Bro, this is getting... We can always extract a set from a single object category. What do you mean set? This set is the set of morphisms. The adders in our example. Is that not an object? In other words, we have the home set MMM of the single object M in the category big M. What? We can easily define a binary operator in this set. The monoidal products of two set elements is the element corresponding to the composition of the corresponding morphisms. The monoidal product of two set elements is the elements corresponding to the composition of the corresponding morphisms. If you give me two elements of M corresponding to f and g, their product will correspond to f of g. Why? The composition always exists because the source and the target for the morphisms are the same object, yeah? Yeah, and it's associative. The identity morphism is the neutral element of this product, so you can always recover a set monoid from a category monoid. What? For all intents and purposes, they are one and the same. But what is it saying? So a set monoid is the same as a category monoid? Is that what it's saying? There's just one little nit for mathematicians to pick. Is that where nitpick comes from? Morphisms don't have to form a set. In the world of categories, there are things larger than sets. A category in which morphisms between any two objects form a set is called locally small. Wait, so are sets in category theory? A category in which morphisms between any two objects form a set. It's called locally small. As promised, I'll be mostly ignoring such subtleties. What? But I thought I should mention them for the record. A lot of interesting phenomena in category theory have their root in the fact that elements of a Hom set can be seen both as morphisms, which follow as composition, and as points in a set. Here, composition of morphisms in M translates into monoidal product in the set M, MM. Here, composition of morphisms in M translates into monoidal product. I did not really understand that entire last, chapter. In category theory, we try to get away from sets and elements and instead talk about objects and morphisms. So let's change our perspective in a bit and think of applications of bearing operators, moving or shifting. That's a function defined on the set of natural numbers. In general, for any number n, there is a function of adding n, the adder of n. So the adder is a function. How do adders compose? Yeah, so 5 and 7 would be plus 12. So the composition of adders can be made equivalent to the rules of addition. Oh. Not really though. I mean, I guess an adder 0 composed with an adder 5 will give you the adder 5. So then you can lift a value into the adder, kind of. It's kind of weird though. Do you still have to define the rules of addition to do that? No? Okay, whatever. Notice that the composition of adders is associative, because the composition of functions is associative. Right, so this is just saying that, yeah, you can interpret it however you want, and that is one way in which it works, right? So traditionally you would think of an append as m, in this case m plus m produces an m, right? Or you can think of it as, we take an m, and then turn that into a function of m. So let's say I have 5 and 3, right? So 5 and 3 would return 8. But I could do 5 with an adder 3. So a function that takes 3 and returns 3. So if I return that... Wait, what? I don't even know anymore, dude. A blob with a bunch of morphisms. Okay, so the adders... Okay, so there are no values, it's just the adders now. A monoid is a single object category. Okay. String concatenation is okay. So there's appenders, prependers, and appenders, yeah? So this is where I got lost. You might ask the question whether every categorical, so every monoid, or every monoidal category, is there a difference between a categorical monoid and a monoidal category? Is there a difference between a categorical monoid and a monoidal category, and even a monoid itself? Is that even a term? They are different. A monoid is a plain set S. So it's only sets with an associated binary operation and any element, n plus 0. A monoidal category is a category C equipped with a bifunctor, yeah, a unit object I, and coherence isomorphisms, left and right uniters. Right, so that's what I saw on Wikipedia. Satisfying pentagon triangle axioms is a category that behaves like a monoid up to isomorphism. Objects don't have a strict product, but one that's associative. Oh. So there's a monoid, which is actually just a set, and this monoidal category, which is a category that acts like a monoid. And then there's a categorical monoid, which is a monoid object in a monoidal category. So given a monoidal category C, X, or C, whatever I, a monoid object is an object M, where M is an element of the category, with morphisms U and eta. Wait, so this is also in Wikipedia. Satisfying, see, I don't know if the book will, but I kind of wish it did like introduce those, because I feel like it'd be easier to to use that official mathematical notation to understand it. I hope it does at some point, because like I want to understand the maths, not just like the concept. Because like, the math gives it a formal notation that I can refer to in the future. This generalizes ordinary monoids. Taking C equals set recovers plain monoids. Taking C equals vect gives associative algebras. C equals cat gives strict monoidal categories themselves. I'm reading category theory. What's category theory for programmers at the moment? And I'm wondering if it goes on to explain this mathematical notation. Right now, it's introducing the concept of a monoid and categorical monoid, but without the actual symbols and diagrams. It does. Later than you might expect. Next chapters, okay. Okay, as long as it comes, as long as it will come, then that means that I can revisit this later, hopefully with a better understanding. But this like is kind of exposing me to the concept. So, a unique set with. Also, can you explain to me why a monoid is a set? I thought set theory was just one concrete instantiation of category theory. A monoid isn't inherently a set. The classical algebraic definition just happens to use one. A set S with a binary operation and any self-existent intervals. That's a concrete version. It's the reverse. Historically, set theory came first, yeah? Yeah, it's a generalization of patterns seen across set theory, algebra, topology. So so the category of sets and functions, right? So monoid is in set. Right. Okay. So I'm guessing Haskell follows the... Does that mean that Haskell's monoid is a set monoid? It is. What? Here is a type. And the categorical view of Haskell. Types are objects in the category Hask. Yeah. Well, no, it says objects though, but in the category. Hask is roughly equivalent to set. And there's laziness and also bottom. And there's strict. Okay. Why did I scroll down when I didn't scroll? Oh no, I did. Defines a unique set with binding operator monoid. Turns out that we can always extract a set from a single object category. Why? This set is a set of morphisms. The adders in our example. Okay. In other words, you have the home set M to M. I thought home set M meant like... Oh, no, it means the morphisms go from itself to itself, right? Like, if the set contains adder 3 and adder 5 and adder 2, then there's a morphism from adder 3 to adder 5, but like that's in the same set. Okay. Okay, fine. So generate a free category from a graph with one or no edges. What kind of order is this? A set is attached with the inclusion relation. A is included in B if a element of A is also an element of B. A is included in B if every element of A is also an element of B. Are there answers like at the end of the book or something? A is included in B if every element of A is also an element of B. Right, yeah. So like 1, 2, 3 is included in 1, 2, 3, 4, 5. But it's also recursive, right? Or like, so like A is included in A. I think. But there isn't a B to A. So there's an A to B, but not a B to A. I guess. Is that so? Then will that be a pre-order? Total order. No. No. All requires that all objects are related to each other. So yeah, so I guess this is actually a total order then, because any set A and B will have a relation, right? C++ types with the following subtyping relation. T1 is a subtype of T2 if a pointer to T1 can be passed to a function that expects a pointer to T2 without triggering a compilation error. So that was a total order? Because, like, if I can pass, like... Wait, no. I guess this one's actually a... It's either a partial order or a pre-order. Like, let's say I take, like, 2 and 5, right? Like, I can't say that, and like this is with less than or equals. I can't say that 5 is less than or equal to 2, but I can say that 2 is less than or equal to 5. Therefore, the relation exists to some capacity. But for A and B, if I have like 1, 2, like if A is a set of 1, 2 and B is a set of 3, 4, there's no relationship either way. So that would be a partial order. Pre-order would be exactly 1, right? So for this one, for C++ types, like let's say I have an int pointer and a char and a, oh well, C++ makes it quite hard actually. Say I have like an int pointer and a standard string pointer. Neither is a subtype of the other, so that must also be partial order, right? Is that the same as A, really? More or less. Considering that bool is a set of 2 values, true and false, show that it forms 2 set theoretical monoids. Forms 2 monoids with respect to respectively operator and an or. Right. Okay, so like do this. Bool with I think true forms a monoid under the AND operation, right? Because true and true equals true. True and false equals false. Yeah. So like, well, about like true and x equals x under all circumstances, right? And true, no, and A and B and C equals A and B and C. And then bool with false forms a monoid under the OR operation. So false or x equals x, right? So like true or false is true, false or false is false, and A or B or C equals A or B or C, right? Like true or false is true or false, true or false or true. Let's say true or false or true gives you true or false. So true or false is true and then true. Likewise, true or false is also true. Okay? Represent the bool monoid with the AND operator as a category. List the morphisms and the rules of composition. List the morphisms and the rules of composition. Like what? Like there's the identity morphism, right? Which just puts it with true. Rules of composition? I don't know. And oops. Yeah. Bool monoid and category, yeah. List of morphisms and the rules of composition. Like false as well? Is that a monoid? I don't know. Like there's a morphism false as well. It's like and false, which is always false. Is there a thing in category theory for that as well? Where like there's an operation such that the units, well, not the units, but like some special thing, x plus a equals x. So like the overriding kind of thing. Like I guess like the opposite of a monoid. So like there's let's ask actually. If bool with true true forms a monoid under and is there a category or is there a label for bool with false under and where true and x equals x with unit equals true with special equals false where special and x equals special. An absorbing element, a zero element or annihilator. In semigroup monoid theory is like a whole thing. Given a set with binary operations, an element z is absorbing. Okay. So there's the identity element and the absorbing element. Right, yeah, so like in multiplication, 0 is the absorbing element, right? In addition, I don't think there is one though. It's interesting how Boolean logic can be expressed via multiplication, right? I think. Is that true? Like true and true would be 1 times 1, which is 1, true. True and false would be 1 times 0, which is 0, right? And then false and false would just be false, so 0 times 0 equals 0. And then I guess for the other one, it would be, like for or, would that be addition then? Wait. Would that be addition? 1, so true or true is true. 1 plus 1 is 2. True or false is true, so 1 plus 0 is also true, 1. I mean, if you say like a limit of 1 maybe, and then like 0 plus 0 is 0, right? Is there something there? Hold on. Not really sure what this is asking. It got me thinking. Apparently, in monoid theory, the identity element is the unit. So for bool under and, so for bool with and, it's true. And there's also the 0 element or annihilator. Absorbing element which does the opposite, such that the absorber operator x equals absorber. So for bool with and so false for the same example. Also, another example would be the absorber element for multiplication being 0, since anything times 0, well, yeah, since x times 0 equals 0, and then the identity element is of course 1, since, well, for all x, right, since x times 1 equals x. And this gets me thinking about Boolean, about the relation between multiplication and Boolean logic. Consider and with true and false. And can be represented via multiplication, where true equals 1 and false equals 0. Right? Because like 1 times 1 equals 1 is true, and true equals true. 1 times 0 equals 0 is true, and false equals false, and 0 times 0 equals 0 is false, and false is false. And likewise, or can somewhat, and interestingly, or can somewhat be represented by addition with the same values. 1 plus 1 equals 2 is true, and true or true equals true. If we treat any positive value as true. But also treating values greater than 1 as true. Yeah, and then 1 plus 0 equals 1 is true or false. Is true. 0 plus 0 equals 1 is true, false, or false equals true. I'm trying to think. -1 plus -1 and -2. What if it was minus? -1 minus -1 is 0. 1 minus 0 is 1. Nah, that wouldn't work. Huh. This is also particularly interesting because if it's implied that AND can be represented by multiplication and OR can be represented by addition, that it makes product types X and Y and sum types X or Y make a bit more sense. So, hold on. Is there any relationship between AND being multiplication and OR being addition? It also makes me wonder, does that explain why X, why a tuple X and Y is called a product type, why X or Y is called a sum type? Yes to both. What? So bool or AND forms a semiring, a Boolean algebra, which is a special kind of semiring. What? Where OR plays the role of plus and AND is times. AND distributes over OR. Just like, oh yeah, also this, right? X times Y plus Z. AND has identity true, like 1, absorbing element false. OR has false like 0, and unlike real addition, OR also has an absorbing element true. True, oh, okay. Which real addition doesn't have, so the analogy isn't perfect. Yeah. Right? Like, in addition, like, 1 plus 1 is 2. 1 plus 0 is 1. Interesting. All you can say is that it's more than 0. This is why it's called Boolean algebra. Boole built it explicitly on the analogy with ordinary algebra using plus times notation originally. Did he? Apparently, when, was it John Boole? I forgot his name. When Boole first created Boolean algebra, he did in fact use the symbols plus and times. Accordingly. Product types. Cardinality. If type A has A values and B has B values, and the product type AB has A times B values. Okay. It turns out product and sum types actually get their names from cardinality. What's the word for this again? The something product, Cartesian product. So product slash sum types is the cardinality of Cartesian product. That's crazy, but actually it's from cardinality. If I take the Cartesian product of A and B of two types, or of two sets A and B, their cardinality no. If I take two sets A and B and combine them into a tuple type AB, their cardinality, the number of possible values under this set is the cardinality of their Cartesian product. Likewise, if I take those sets and say that my value either belongs to set A or B, A or B, whatever, then the number of, is it maximum number of possible values though? It's maximum, right? It's a disjoint union. And the number of possible values is the cardinality of A plus the cardinality of B. Plus so mathematically A times B. Likewise, so that's A, well, the cardinality of A plus the cardinality of B. That's crazy. Mind blowing. This cardinality fact is also why categorical products / coproducts get named product / sum in the first place. In set, the categorical product literally is the Cartesian product, and the coproduct is a disjoint union. That's freaky. Okay, the more you know. Represent addition modulo 3 as a monocategory. How though? Like, I don't really understand that. I mean, I can say that the unit is still 0, right? Wait, are there 2 units? Is 0, because the unit could also be 3, right? But more, well, I guess there were 2 different monoids for that. What is modulo 3 as a monoidal category? What's funny is that, like, I did know about the cardinality thing before, I just forgot about it. Yeah, no, it's 0. Because there's only 3 objects, 0, 1, 2, 3 is not possible. Right, so a strict monoid has the associator and unitar be the identities. Okay. Sure thing. Okay, that's it for this chapter. Okay, I mean, that's quite insightful, particularly at the end there. Yeah, so like, yeah, so like, it really doesn't make sense to represent A and B as A plus B. Because like, it's not A plus B. It refers to the cardinality, not the actual action of like joining the sets. So yeah. Yeah, literally. That's kind of funky. Okay. Cool. I wish someone like responded to this, because to me it's really interesting. I mean, first class patterns, but oh well. Okay. Okay, so let's port these notes. So category is great and small. What the hell? Things seems to be bugged. So you can fix it here. It is bugged. Huh? I think I have to quit. weird. Yeah, my name kind of just crashed. What? That doesn't happen very often. Okay. Strange. Back into manually, I guess. Right. Three categories, great and small. So the most short category is one with 0 objects. Is that a note? Category 0. Okay. So the category with 0 objects is denoted as category 0. The category of all categories is denoted as that. The category of all categories is denoted as B. Category 0. In category 3. A 0 object within a category. Yeah, no, that's high dimensional. The 0 category. Category of all categories. Oh no, cat is a category of the small categories. Okay. A category of all small categories is noted as okay, good to know. A free construction is possible to complete a given structure. Right. What is that keybind that adds that? It's so annoying. Okay. Let's copy that. Okay. Sorry, that's 3.2 simple graphs. This is 3.1. No objects. Yeah. And we got orders. So a preorder is a category where there is at most one morphism going from any object A to any object B. As a preorder, it's a thing category. I don't really have like a note for that, so I'll just paste it as is. That's weird. Oh, A and B are given a different font? Right. Yeah, same effect, I guess. Latex is just font rendering, right? Like, you can copy latex as a style. A set of morphisms from an object A to object B in a category C is called a Hom set, which it has this. Every Hom set is a preorder. Oh, in a preorder. Okay. Right, yeah. Yeah, not quite. So object A to object B in a category C. Math boldface. Yeah, it's called a Hom set. Written, oops. What? And it's written as C of A and B. Oh. Or sometimes Hom C. Hom sub C. Partial orders can be sorted using topological sort. I have a note for that one. Just missing that. I don't know what it actually is, but yeah. Monoid as set. Finally a word. Ubiquitous. I thought ubiquitous always meant like equal, you know? Like him and like them two are ubiquitous. As in like you cannot have one without the other. That's what I thought it meant. And maybe some people do use it in that way. I don't know. Ubiquitous. Natural numbers is 0 from a monoid under addition. Yeah. Consistencies are part of the definition of a monoid. No. I don't understand what keybind it keeps doing that thing. But it happens when I save. Don't know. Okay. Here's a question. Yeah, so it says unprovable. I need to check that. Okay, or undecidable. Extension equality. Extensional equality states that the results should be the same for the same inputs, that the results of both functions should be the same for the both same inputs, permutations doesn't matter. Yeah. It's weird. While reading this, I didn't even notice that like it did this thing, you know, like the sum hyphen times. Like I can just filter it out. It's kind of interesting. Points. What? It's weird. Oh, because it's a different symbol, not X. Right. Okay. Monoids category. I had one note there. And a lot of confusion. Monoid as category. Kind of weird that I needed one note for so many questions. I guess I'm just absorbing the information. A monoid is a single object category. Not really though, is it? A monoidal category is. Is it even true? Or is it that a categorical monoid is a single object category? happened again. But how did it happen? Like you inserted a checkbox for some reason. Okay. Then challenges. This. I'm really overusing my thumb, I'm noticing. I need to get used to using my other fingers to press like shift and stuff, and I control and shift, because like right now, like I have a really bad habit of always using my thumb to press like alt, control, and even like shift sometimes. In fact, no, shift every single time. And even escape as well. Like it's really bad for my thumb. I just get used to like, using my pinky and my ring finger more. Like here, like Windows 2, press my finger. I should instead do my pinky or something. I think Windows 2 is awkward anyway. I don't know. Like none of my fingers really do it well, because the two things are like right on top of each other. Yeah, like here, like what finger do I use realistically? I just misclicked. No. Just takes getting used to. Okay. we'll leave it there then. Alright, so next step to do would be to go through these notes and save, and yeah, like, well, go over them and like turn them into my atomic notes and whatnot, but I'll do it not now because I'm a bit tired already. It's already midnight. Whoa. But yeah, cool. I understand a bit more now. Just keep going and see how much I understand by the end of it, or if I quit, then how much I understand at that point. So yeah, I'm gonna keep on reading this until I finish, right? Or again, give up. So I don't think I'll be reading anything else in between. And in the meantime, I'll just keep on working on True as well. And at some point, I'll get back on my C++ game engine, but what? Yeah, I guess I will at some point. Also, well, mind you, there's other things I want to do first. I need to sort out these. So tomorrow the package arrives with my USB thing, so I'll use that as an excuse to finally sort out my files. Someone asked me for a file thing, so I'll be able to send it to them. And I also, one of my friends asked me to make a GUI for his modding tool, so I can use Qt, and it'd be fun, wouldn't it? A bit of fun trying out Qt for that, because I've tried Qt before, but I didn't have like anything serious to make with it, so that project kind of died immediately. Otherwise, I've used Qt for QuickShell, so like I do know like, you know, a decent amount from that alone, but I haven't really used it like beyond that. So this would be my first time using it in a proper C++ application. So expect me to do that at some point. Right, 2 chapters in 4 hours. Talk about efficiency.